separation of variables. That's the method we're going to learn today, and I'll just explain what you're doing. But it's a technique used. I don't know where I wrote that. So that you rewrite the equation. A technique used so that you rewrite the equation so each variable is only on one side. That's the whole point of it. They call it separation of variables because you're going to want all your x's on one side and dx's and anything variable with an x and all your y's on the other side. So you start off with a function defined with y, and then you're going to have a derivative somewhere. And then the other side, you're going to have another function defined with x. Okay? So that just means a function. No. I mean, some say ay and bx, whatever. It's just a function defined by y, a function defined by x. You're going to do what we did yesterday, which is multiply by dx, because you want all the x's on one side and all the y's on the other side. So you'll have now a y and an x, and then you just do what we were doing, which is integrate both sides. Okay? So I'm going to do 3 problems to you. They're going to start off easy, medium, and the last one will be a little bit harder. But you'll be able to do then I think there's only 6 problems left of homework tonight, if I remember, because it's whatever sheet yesterday was. It's the finish off that sheet.
Yeah, I think that's right.
All right. Bless them. Just bless them. All right. So let's do the first one. So dy dx equals 3y squared x squared. So again, it's mixed up your variables here. Your job is to put all your y's on one side and x's on the other. Now, I tend to put all my y's to the left and all my x's to the right because I kind of do it like I've solved for y. So I always solve for y on a left side. So what would you do to get this y over to that side? Divide. So I'm going to divide by y squared, but that's going to look weird here. So I'm actually going to multiply by 1 over y squared. Like I don't want to write dy dx divided by y squared. So I'm just going to write 1 over y squared, which is the same as dividing by y squared. So that would cancel with that. And then do you see how dy dx has an x on the bottom? So I'm going to multiply by dx now on both sides. And that would cancel with that. So now what do I have left? On this side I have 1 over y squared dy. On the right side I have 3x squared dx. Do you see now how I got all my y's on one side and all my x's to the other side just using simple algebra? Haven't done anything crazy yet. Okay? Now comes the calculus part, because again, the hardest part of calculus is just doing algebra. We're going to integrate both sides with respect to their variable. Okay? So this one, I would rewrite this obviously as y to the negative 2. And what do you do when you have any constant to a negative 2? Well, you just add 1 and divide. So what does that become? Y to the negative 1, divide by a negative 1, yeah? So negative. Don't put the plus c here. The c is a constant no matter what. We're always going to keep it to the right. So it's just a c that you're going to keep to the right. So I'm going to let the right have the c. So now I'm going to integrate this side, add 1 and divide. What would you get? X to the third. And then put plus c on the right side. Okay? And now you're almost done. Once you get it you've integrated it, now solve it for y to the best of your ability. Sometimes you won't have to. But again, this is really just negative 1 over y equals x cubed plus c. I don't know if everybody knows a trick of stuff. Maybe you don't. Or I was showing the other class. They're like, huh? You do know if you have 1 over y equaling another fraction on this side, that's the same as y over 1 equals 7 over 3, right? Yeah. It's just the flip. So if I just wanted to solve this, this would be y equals, and I would flip this. Isn't this over 1? So I'd flip this, and then since this is negative, I'm going to make that side negative. And now you've solved for y.
What determined
And that's it. Okay. So the hardest thing is you're going to get all your variables of y's on usually left, all your variables of x's, integrate, solve for y. That's literally the steps. So that's an easy problem. Let's try medium. Medium. Exactly. All right. This is notation for dy dx, right? Y prime, just again is another notation for dy dx. And then you've got xy obviously on this side. And then I'm going to bring, again, I like my x's to be on the right. So I'm going to, and I like ln's to be positive. So I'm going to call it ln x. So now, if I want to get all the x's on the right side, what am I going to do with this x? Divide by x. But again, try to write it like 1 over x. And you'll see why in a minute, maybe. Some of you can see it already. And then also the dx needs to go over there. So I'm going to also multiply by dx. And so now, again, what do I have left? Many of you could probably skip that step. You could probably already see it. But you have a y dy equaling ln x 1 over x dx. Now, once you get it to that point, you're going to integrate both sides. Add 1 and divide. What would this side become? Okay. This side is going to be a little bit more trickier. This is why this one's a medium problem. This, what's the derivative of ln?
1 over
You should know that these two are really derivatives and original of each other, which means that, watch, this is a u problem. This is the du. 1 over x dx.
Oh, yeah.
So watch how I rewrite this now. This is the integral of that's your u, that's your du. Okay, let me cover this up. If you just had this, what would you do now? Add 1 and divide, right? If it was u du, don't look at this because you've already replaced it. You would add 1 and divide. So you would end up getting u what over what? U squared over 2. I'll just write it for what you would get, plus c. But now replace that u with what? So it's ln x squared over 2 plus c. Okay? Now, we're not going to solve this one for y because they gave us...
Why is there C on the bottom? That's supposed to be 2.
That's supposed to be 2. Thank you very much. I appreciate that. I don't know why. They gave us already up here, they want us to find a particular. So this, a general solution is when you solve it for y. There's your general solution plus c. This is a particular. So you can really just stop right here. You don't have to solve for y once you get to this point. This is your x, agreed? And then this would be the y that comes out. So I'm going to replace y with 0 squared over 2, which is just 0,
Okay.
just so you know. And I'm going to replace x with 1, ln of 1 squared over 2 plus c. And now I can find c. Anybody remember what the ln of 1 is? It's 0, actually, yeah. So this is 0. This is 0. Guess what c equals?
0.
And then what you do there, then this is the last step. You're going to now replace this equation with 0. But then that would just be y squared over 2 equals ln x squared over 2. And then really, do those 2's matter?
No.
No, because if you times by 2 times by 2, they just go away. So y squared equals ln of x squared. Now, could you take a square root and then solve for y? Yes, you'd put a plus or minus. I will tell you that my professor, anytime we got squareds or fourths, we would just stop. Because again, this is a particular solution, and I would get some other extra information for anything else that we would be solving. So that would be good enough for me. This right here is the general. That's your general solution. And that's your particular. The y squared. This is the hard problem. If you can understand this, you're going to be gold today. You're going to be gold, okay? Promise. All right. So, again, what I'm doing in my head, as I'm kind of going like crisscross method. I always try to do that. So I'm going to go ey squared y. I'm going to switch those around, y prime. I don't know why I write it like that, but that's just what I do. And then 5x squared times 1 is 5x squared. And then again, what is y prime really? Okay, so we're going to keep the dy on this side and put the dx on that side. So I'm going to now rewrite this as ey squared y dy 5x squared dx. If you don't know what I did here, I literally separated the dy on the left, the dx on the right. Okay? Now, we're going to integrate, because now all the x's are on one side, the y's are on the other side.
There are more letters than numbers.
When there's more letters and numbers in math,
Good times.
we lose the plot.
Good times.
Yeah, we will.
All right, so let's kind of just do this one. This side is much easier. Add 1 and divide. What would you get? 5x cubed over 3. Yep, I'm going to put the plus c again. I always like to put it on the right. That's just where I put it. And now this side, when you have an e to anything other than x or y, you have a u problem. This is your u, but this isn't bad. What's the derivative of y squared? I don't see a 2y, but I do see a y. So what do I do with that 2? Somebody learned something. That's my kids. My kids learn. Other kids don't learn. Okay, so this right here is du, but it's a half on the outside. So this right here in the box is half du. This is e to the u. What is the integral of e to the u? Well, it's e to the u, right? With a 1/2 in front, it's 1/2 e to the u. Again, what is my u? What am I going to replace it with? Y squared. Equals 5x cubed over 3 plus c. Now, we're solving for y. How do I get y out of the expo? Brilliant. Sorry, that was exciting. I was very excited. I'm so proud of you. So excited.
Are the middle-aged women still taking this class?
Are the middle-aged women still?
They're going to hear this.
Sammy.
This is live.
You're one of the moderators.
Wait, that's a valid question.
They never took this class. They took 171. That was.
Okay, that's like,
They won't
they're
get
all
it.
good.
Thank God.
They're all good.
Okay. First thing though, I want to get rid of the 1/2, so I'm going to multiply by 2. Let me explain something when you multiply by 2. You do not have to distribute the 2 to the c. Because the c is already known to be a constant. You're multiplying by it. You don't need to. We already know it's going to be some kind of constant. But the 2 does need to distribute to this. So this does need to become 10x cubed over 3 plus c. You just leave it as plus c. Okay? Now, we're going to do what you just said to do, which is ln both sides. And what will happen is the ln and the e cancel. Let me move up here. You're left with y squared equals the ln of 10x cubed over 3 plus c. And honestly, I'd be happy with that. You can take a square root and write it as y plus or minus the square root of ln 10x cubed over 3 plus c. If you understood that, my friends, you've done the hardest part of the worksheet. And then, God bless. Now I will pause the video and really edit it out. Edit. Leave it.